I'm going to solve a problem with equality restrictions. Using one of two methods, we have to do it. Firstly, we need to read perfectly well the problem and write down the objective function and the restriction. We have this profit function, where the quantity of products exported to France are X and the products exported to Germany are Y, but these quantities are measured by thousand. This is an important data, and we need to take account to write the final solution. The sum of both are equal to 10.5. These are our restriction. X plus Y are equal to 10.5. A. Calculate the optimal combination of both products to obtain a maximum profit. Now it's time to solve a problem, because we have perfectly clear the data we need. We can use a substitute method, because the restriction is a linear function. This method consists on transforming the initial problem with restrictions into a problem without restrictions, which we already know how to solve. How we can do it is easier. We work out one of these variables, for example, x. Now we have the value of x depending on y. We substitute this value inside the objective function, and we can obtain a function without restrictions. Now it's easier for us to solve the problem. We know the steps. Step 1. Calculate the first derivative of the function. And the step 2. We need to make equal to 0 the solution of the first derivative, and we can obtain the value of y. We need to know if this value can be a maximum or a minimum. We know that the Hessian matrix is made by the second partial derivatives of the function, but in this case we only have one variable, and the Hessian matrix is the second derivative. With the sign we can obtain doing the second derivative, we can know if y can be a maximum or a minimum. We can see minus 14 is less than 0. That is to say, this value is a maximum of the objective function. Now it's time to substitute the value of y in x function to obtain the value of x. And this is a point where the function maximizes its profit. And we know that each point y equal 9 divided by 2 and x equal to 6 can be a local maximum of profit function when x plus y are equal to 10.5. So the answer for the question A will be that the firm maximizes its profits when exports 6,000 units to France and 4,500 units to Germany. Hence, its profits are equal 41.5 units. Now it's time to solve the second part of the problem. What is the approximate variation in the profit function if the firm now uses 10,000 units of both exports? We need to use the Lagrange method. Lagrange method introduces another variable inside the objective function to obtain the solutions. How to do it? We need to make equal to 0 our restrictions and introduce the multiplier of Lagrange. Lagrange multipliers measures the sensitivity of the optimum value of the objective function against the variation of the restriction constants, that is to say, how the objective function changes through the variations by 1 unit on the independence term of the restrictions, that is to say, how the objective function changes through variations by 1 unit on the independent term. How to do it? To do it, we multiply the multiplier by each restriction that previously we make equal to 0. So we get a new function with the new variable. As we have to do a partial derivative of this new function, we can solve the operations. Now we have these three partial derivatives to solve the problem and find the values of x and y. To do that, we need to make equal to 0 these solutions and solve the equation system. But as we have the solutions of other part, just substitute the value of variables in the equation and we obtain the value of multiplier of Lagrange. So, the value of multiplier of Lagrange is 6, and we know that the independence term decreases by 0.5 units. Then, when the profit changes by 6 plus 0.5 equal to 3 units, so the maximum profit will decrease 3 units when the total amount exported is 10,000 instead of 10,500 units. That is to say, if we increases by 1 unit the independence term, the objective function, the profit function, increases by 6 units. As in this case the independence term decreases by 0.5 units, the objective function changes 3 units. 3 units when the total amount exported is 10,000 instead of 10,500 units.